Welcome to day 25 of our Python course, where you will dive into generators in Python. Generators are a powerful tool for efficient iteration and lazy evaluation. Let's explore how they work and how you can use them in your code. First, let's define what a generator is. A generator is a special type of iterator in Python. Unlike regular functions that return values all at once, a generator yields one value at a time. Instead of using the return keyword, it uses the yield keyword to return values. This allows the function to pause and resume where it left off, making it memory efficient. Here's a simple example. We have a function called count up to, which generates numbers from 1 up to a specified limit. Notice that we use the yield keyword inside the while loop. Every time we call next on the generator, it yields the next number. This process continues until the generator is exhausted. So, why use generators? The main advantage is memory efficiency. Generators don't store the entire sequence in memory. They yield one value at a time. This is especially useful for large datasets. Additionally, generators use lazy evaluation, which means values are computed only when requested, leading to faster performance in many cases. Let's compare a list-based approach to a generator-based approach. In the list-based example, we return a list of squared numbers all at once, which can be memory intensive. In contrast, with the generator, we yield each squared numbers one by one, making it more memory efficient, especially for large values of n. Generators work seamlessly with loops. You can iterate through a generator using a for loop, and it will automatically call next on each iteration. This allows you to process items one by one without needing to load everything into memory upfront. Generator expressions are similar to list comprehensions, but they use parentheses instead of square brackets. This makes them more memory efficient since they return a generator instead of a full list. In this example, we are squaring numbers, but we are doing it in a way that does not require storing all the results in memory at once. Generators are also useful for processing large files. In this example, we define a generator that reads a file line by line. The generator yields on one line at a time, so you don't have to load the entire file into memory, making it ideal for processing large files efficiently. Generators can even be used for creating infinite sequences. Here, we define a Fibonacci generator. Instead of calculating the entire sequence, we use yield to generate each Fibonacci number on demand. This allows us to work with infinite sequences, one number at a time. Generators can also be combined with functions like map, filter, and reduce. These functions allow you to apply transformations or filters on the values yielded by a generator. For example, we can square the numbers, filter for even results, and then accumulate the sum of those even numbers, all using generators. To sum up, generators are a powerful tool for efficient iteration and memory management. They provide benefits like lazy evaluation, which computes values only when needed, and they are ideal for working with large datasets, infinite sequences, and real-time data processing. Understanding generators can help you write more efficient and scalable Python code.